Hello, let's see the different loads coming on steel structures. These are the common loads considered while designing the structural steel buildings or structural components in the civil engineering. So, the loads considered are dead load, live load, or imposed load or superimposed load, then wind load, snow load, seismic load. These are the loads considered, and these are mentioned in the IS code. So the first one is dead load. Dead load in steel structures is nothing but a gravity loads and are relatively constant over the time. These are also called as permanent loads because they don't move in their entire lives. Okay, they are the self weight of the structural members or materials used for the construction. Obviously, these are immovable loads or permanent loads, and therefore their self weight is considered for the design. This includes weight of beam, slab, column, etc., and the elements such as weight of walls, partitions, floors, and roofs. All these members or parameters, these are the permanent members of the structure, and therefore the load of these members is permanent load, and that comes under the dead load. Then second one is live load. Live loads are also called as imposed loads or superimposed loads. Those are not permanent and may change in position and magnitude. The loads of furniture, equipment, and occupants of the structure, etc. These loads are the movable loads, and therefore they can change their place according to time, and that's why these are termed as live load. The examples: furniture, equipment, occupants of the structure. These are the live loads. They can change their position and they are movable loads. And this is mentioned in the IS code IS 875 1987, and the dead load were mentioned in the IS code IS 875 1987 part 1, and live load is comes under the IS 875 1987 part 2. Then third one is wind load. The wind load is more significant in case of tall structures. Especially wind load is considered when the uh, structural member or structural steel structures goes up to 3 and 4 floors or more than that. Okay, in that case only wind loads are considered. The wind pressure intensity at any height if the structure depends upon basic wind speed, shape, and height of the structure, topography of surrounding ground surface, and angle of the wind attack. These are the some parameters on which the wind speed is, or particularly wind load is, depends. Basically, wind speed, what is the speed of wind which is acting on the structure, what is the shape of structure, and then the height of structure, These all are the important parameters which are to be considered during the wind load calculation. Then it is considered as per the specifications given in IS 875 1987 part 3. Okay, these are these are comes under sequence: dead load in part 1, live load in part 2, and wind load in IS 875 1987 part 3. Okay, so these are the some basic loads. Along with this, there is another important load is snow load in the areas of snowfall. Okay, snow load is particularly considered only in the areas of snowfall, and allowance for snow load is considered. Okay, where the snowfall occurs, in that areas only snow load is considered when designing the steel structural members. It depends upon the shape of the roof as well as the roofing material. Obviously, it depends upon the shape of the roof, what type of roof construction is there, and what type of roofing material is used for the construction. These parameters are very important while designing the slow load calculations. It is variable load that may cover entire roof or part of it. Okay. Then the last one is seismic load. When a structure is subjected to ground motions in an earthquake, it responds in vibratory fashion, and this load shall be assumed as per IS 1893 2002 part 1, and the title of that IS code is criteria for earthquake resistant design of structures. Okay, criteria for earthquake resistant design of structures. This is a title of that IS code, and seismic loads are totally mentioned in this particular IS code. And seismic loads are, it is also a earthquake loads. Okay, seismic load nothing but earthquake loads, and that's why it responds in vibratory fashion. So these are the typical loads considered while designing the structural steel sections structures. So all about the first topic is this, and thank you so much.